This is WAEC June 2022 General Mathematics Paper 2, and we are answering question number 4. And the question says in the diagram BCD is a cycle, and that cycle has center at E. This is the cycle BCDE. The center of that very cycle at the point E. And angle BCD is given by the expression 2x plus 40 whole degrees. 2x plus 40 whole degrees, look at it, is marked in the drawing. Similarly, angle BAD is given by the expression 5x minus 35 whole degrees. 5x minus 35 is also marked in the drawing. Angle BED is also given by the expression 2y plus 10 whole degrees. 2y plus 10 whole degrees is also marked in the drawing. And the last angle ADC is 40 degrees. Look at it, angle 40 is also marked. So what you asked to find is question number A, the values of x and y, and question number B, the size of the angle ABC. ABC is this very angle. So let's attempt to answer this very question. Solution to the problem. In attempt to answer this question number A, that is determining what is x and what is y. Look at this, these are two variables. So what will come to your mind is having two systems of equations that you solve simultaneously. So you go back to this very drawing. Think which expressions for angle that you now connect so that you now have two systems of equations. So starting with this angle 5x minus 35, 5x minus 35, look at this is an angle at the center, subtended by this arc BD. And that same arc BD also subtend angle 2y plus 10 at the remaining circumference. Remember a theorem which says angle at the center, 2y is angle at the remaining circumference. So I can now use this to have my very first equation in terms of x and y. So I can now write 5x minus 35 equals to 2 times angle at the remaining circumference, which is 2y plus 10. And my reason is angle at the center equals to 2 multiplied by angle at the remaining circumference. So copying the left hand side, I will now have 5x minus 35 equals to 2 times y is what gives you this 4y. 2 times 10 is what gives you this to 20. Taking minus 35 to the right and 4y to the left, you now have 5x minus 4y equals to 55. And you now call this equation 1. So this is one of the equations. So let's go back to the drawing, get another equation. If you now look at this angle here, 2y plus 10, and looking at this angle 2x plus 40, and looking at this is a cyclic quadrilateral. Cyclic quadrilateral. Remember, there is a theorem which connects opposite angles of a cyclic quadrilateral, which says if you add the two angles together, what you are simply getting is 180 degrees. Opposite angles of a cyclic quadrilateral are supplementary. So that will enable you to get another pair of equation, another equation. So I now write 2x plus 40, that is the size of this angle. Add to the size of this angle 2y plus 10, and the result will now be 180 degrees, and this is the reason it is opposite angles of a cyclic quadrilateral. So they are collecting like terms, simply removing this very bracket. You have 2x plus 2y and 40 plus this 10 get 50, and 50 taken to the right hand side becomes minus. So you now have 2x plus 2y equals to 130. So dividing through by 2, you now have x plus y equals to 65, and you now call this equation 2. So it is this equation 1 and equation 2 that I will now solve simultaneously in order to answer this very question number A. So from equation 2, I can now make y here subject by shifting x to the right hand side. That gives me 65 minus x. So where I have y, I will now replace it by 65 minus x in equation 1. There you now have 5x minus 4. 4 times instead y, you now replaced y by 65 minus x equals to 55. So next is to open this very bracket and collect like terms. 4 times 65, and the result is shifted to the right. and minus 4 times minus x, that gives you positive 4x, and the positive 4x added to this 5x, that will give answer 9x. And the result of multiplying 4 by 65 when shifted to the right where it becomes minus added to this 55 is what gives you 315. So next you have to divide both sides by the coefficient of x, which is 9, to get an x. So when that is done correctly, you have x as 35 degrees. So the value of x is now known. And now I'm going to use this value of x to find the value of y. So substituting x by 35 degrees in equation 2, look at equation 2, it says x plus y equals to 65. I'm now replacing x by 35. That gives me 35 plus y equals to 65. And now 35 shifted to the right becomes minus, so 65 minus 35 gives answer y as 30 degrees. So the value of x is now 35 and the value of y is now 30. That means question number A has been answered. So I move to question number B. Question number B, that you asked to find the size of this very angle, angle ABC, this very angle. This very angle, you can take this as a quadrilateral. You have three angles, 40, 5x minus 35, 2x plus 40 is only this that is missing. If you now take this ADCB as a quadrilateral, and sum of angle in a quadrilateral is always 360 degrees. So there I can now determine my angle ABC as 360 minus the three angles. These three angles, 5x minus 35, 40, and 2x plus 40. If I know the size of those three angles, subtract from 360, what remains will now be the fourth angle. So let me have this size of those angles. So replacing x by 35 in here, that will give a result of 140 as the size of this angle. That is 5 times 35 minus 35. The result is now going to be 140. This will be the size of this angle after replacing x by 35. Let me get the size of this angle as well, 2x plus 40. So replacing x by 35, you now have 2 times 35 is 70, and 70 plus 40, that will give answer 110. So which means to find the size of this angle ABC, I'm subtracting 40 and 140, and I'm also subtracting 110 from 360. The remaining will now be the fourth angle. So let me do that. So I'm going to have 140 minus 40 minus 110 degrees. If these subtractions are done correctly, you now have your angle ABC at 70 degrees. And that answered the question number B, and that answered this question number 4 completely. So let me just share with you how this very question is now marked during the marking of this very paper. So the very first mark is bonus 1 mark, and this bonus 1 mark when you now have the very first equation. Is using the theorem angle at the center equals to twice the angle at the remaining circumference. If you now connect these two angles together appropriately, you have this bonus 1 mark. The next mark is for getting the second equation, that is connecting this angle 2y plus the 10 and the 2x plus 40 as opposite angles of a circular quadrilateral. You have this bonus 1 mark. In attempting to solve these two equations simultaneously using any of the correct methods, you now have this method 1 mark. So when you now have the value of x as 35 degrees exactly, you now have this accuracy 1 mark. The next mark is another accuracy 1 mark. When you have y equals to 30 degrees correctly, you have this accuracy 1 mark. So question number A has 5 good marks. Question number B, attempting to get the size of that angle ABC by subtracting 3 other angles from 360 degrees correctly, you have this method 1 mark. And simplifying further, you have this method 1 mark, and when you now have the angle ABC exactly at 70, you have this accuracy 1 mark. So if everything is now done correctly, you have this 3 good marks.